Hello Lamai. So let's discuss the questions from the mathematical induction lesson that you get for the short questions. Actually, this is the first pure short question that you get, right? So here it is. I have started to do this 2025 A-level question. Right. You can see there you have to show that this inequality holds for all n is an positive integer. හරිද? එතකොට දැන් inequality එකක් අපි හදන වෙලාවටත් ළමයි what you have to do is you have to take the left hand side separately, right hand side separately, and then you can show that the left hand side is less than the right hand side. Then that results hold for that particular value for n equals 1, let's say, right? So I took n equals 1 here. When n equals to 1, you can see the left hand side is equal to 9 into 2 to the power n. So 9 into 2 to the power 1, which is equal to 18. Clear? And how about the right hand side? Right hand side is given as n plus 3 factorial. Okay, so when n equals to 1, that is 1 plus 3 factorial, which is equal to factorial 4, and that is equal to 24. 4 times 3 times 2 times 1 is 24. So Pute, can you see that 18 is less than 24? Yes. Then if 18 is less than 24, so the left hand side is clearly less than the right hand side. Therefore, this result holds for or true for n equals 1. That is true for n equals 1. Okay, so the first part is done. Now what should be our next step? We have to do the assumption, right? We have to assume that the result is true for a random value. Result is true for n equals k. මොකක්hari අපි integer set එකේ value එකක් ගන්නවා k කියලා. n equals k කියලා random value එකක් ගන්නවා. එයාට අපි මේක හරි කියලා හිතනවා. එයා k is also an positive integer, right? එතකොට දැන් මේක k ට හරි කියලා කියන්නේ අපි මේ assume කරන්නේ මොකද්ද? That is we assume that 9 times 2 to the power k, right, is less than k plus 3 factorial. මේක තමයි අපේ assumption එක පුතේ. මෙන්න මෙයා හරි කියලා හිතන එක තමයි අපි මෙතනදී කරන්නේ. Can you understand? So you have to always write down this line as assumption, and then you have to write what you assume. Assume කරන්නේ මොකද්ද කියලා හරියට ලියලා පෙන්නන්න ඕන. Can you understand? Right. And after that, now we assume for k, what is our next step? We have to show that this is true for n equals k plus 1. We have to show that this is true for n equals k plus 1. හරි. එතකොට දැන් ඔයා හිතන්නකෝ n equals k plus 1 නාම right hand side එකට මොකද වෙන්නේ? Yes, that becomes, you can just observe, right hand observe, see, 9 times 2 to the power k plus 1. This is the left hand side. Okay, so you can see 9 times 2 to the power k plus 1. I can further write, I mean, there will be first may line එක use කරන්න ඕනේ නෝඩ මේ k plus 1 එකේ part එක හදන්නත් you must have practiced these kind of questions. If you know about that, definitely keep in your mind or assumption එක use කරලම තමයි ඔය k plus 1 part එක හදන්නේ. n equals k plus 1 part එක හදන්න නම් ඔය මේ assumption එක use කරන්නම ඕනේ. Can you understand? හරි. දැන් left hand side එක කාටද equal වෙන්නේ, right? Okay, you can see the left hand side equals to what? Yeah, I'll write it again here. Right. You can see that the left hand side is equal to, when n equals to k plus 1, right? When n equals to k plus 1, right? Left hand side is equal to 9 times 2 to the power k plus 1. හරිද? හැබැයි දැන් ඔයා මෙයාව use කරන්න ඕනනේ. එතකොට ඔයා try කරන්න මෙන්න මේක හදන්න. Okay? Because we have to build up an inequality. So we know the inequality for this case. Clear? So you can further write down this as 9 times, right, 2 to the power k times 2. Okay, so the left hand side is equal to this, right? And you know the fact that, right, now this is less than this one. හරිද? මෙයාට වඩානේ අඩු වෙන්නේ. හරිද? එතකොට මෙයාගේ 2 times මොකට කාට වඩාද අඩු වෙන්නේ? මෙයාගේ 2 times ට වඩා අඩු වෙන්න ඕන. Is it clear? Right, so you can write down that. Now you identify that this is may තියන්නේ 9 into 2 to the power k 2 times කියලා identify කරා. එතකොට ඕක පුතේ අපි ලියනවා less than, this should be less than 2 into k plus 3 factorial. Is it clear? Is it clear? So this should be definitely less than 2 times k plus 3 factorial. Clear? Right. Now, what is the reason? ඒ කියන්නේ මේ ආව මේ sides දෙකම 2 ගෙන් multiply කරා කියලා වැඩක් වගේ තමයි කරලා තියෙන්නේ. හරිද? Right? So inequality holds no still. Right. But still, what you have to prove? දැන් ඔයා බලන්න ඔයාලට prove කරන්න ඕනේ මොකද්ද කියලා. ඔයාගේ right hand side එක මොකද්ද හදාන්න ඕනේ? When n equals to k plus 1. මෙතන n equals to k plus 1 ආවම ඔයාලට prove කරන්න ඕනේ right hand side එක k plus 1 plus 3 factorial. Okay, which means that should be k plus 4 factorial. K plus 1 plus 3 factorial means what? K plus 4 factorial. Okay, what do you mean by k plus 4 factorial? Can you represent it using k plus 3? K plus 4 factorial again හිතන්න. දැන් ඔයා මෙතන පෙන්නන්න ඕන ඇත්තටම ඔයාගේ answer එක 9 times root the power k plus 1 is less than k plus 1 plus 3 factorial, which is equal to k plus 4 factorial. තේරෙනවද? මෙන්න මේක තමයි ඔයගේ result එක වෙන්න ඕන finally. Clear? එතකොට ඒක answer එක target කරගෙන යන්න. You just target your answer and move on. Right? That's what we had to do. හරි. මට කියන්නකෝ දැන් k plus 3 වල ඉන්නේ අපේ right hand side එකේ ඉන්නේ. Is there any way to write k plus 4 in terms of k plus 3? ඒ කියන්නේ k plus 3 use කරලා k plus 3 factorial use කරලා ලියන්න විදියක් තියෙනවද k plus 4 factorial එක? Yes. How? k plus 4 times k plus 3 factorial. You know that, no? Right? So we can write 5 as 5 factorial as 5 times 4 factorial, like that. Clear? Same case. Clear? Right. Now, can you observe there, this part, this particular part, right, is definitely less than k plus 4 into k plus 3 factorial. එයාට වඩා අඩුයි කියලා පේනවද? Why? Because k plus 4 is something greater than 2. K is a positive integer, right? K කියලා අපි ගත්ත positive integer එක. එතකොට k plus 4 definitely greater than 2. Can you understand? So when we multiply k plus 3 factorial by 2, and when you multiply k plus 3 factorial by some integer which is greater than 2, then this particular value will be definitely greater than this thing. Is it clear? Right? So we can write down like this. Clear? Finally, this part is equal to what? K plus 4 factorial. So can you see what we have proved is this thing is equal to this and that part is less than this. This is even less than this one. Okay, and it's equal to this one, which means finally we can, what we have got is, right, what we have got is 9 times 2 to the power k plus 1, right? Therefore 9 times 2 to the power k plus 1 is less than k plus 1 plus 1 factorial. Okay, therefore the result is true for, therefore the result is true for n equals k plus 1. මෙහෙමයි පුතේ. දැන් මෙතනදී ඔයා මෙතනදී prove කරලා තියෙන්නේ මෙයා මෙයාට equal. හරිද? එයාට වඩා මෙයා greater than this is greater than that. Clear? එතකොට මෙයා ඊටත් වඩා වැඩි කියලා කියන්නේ හරිද? එයා ඊටත් වඩා වැඩි කියලා කියන්නේ definitely, right, we can write this is less than this. තේරුණාද? So that's actually this, if a is, this is the thing that we used here, if a is less than b and if b is less than c, so we can tell that a is less than c. Can you understand? Right. So then, can I answer the target කරගෙන යන්න. හරි? Right. Therefore, the result is true for n equals k plus 1. Now we can finalize this one using this thing, right? Right, I wrote it here because the same thing you had to write. Sorry, plus 1 uttava. Okay, so what you have to write is this, right? The result is true for n equals, what we proved, the result is true for n equals 1. 1 කියලා integer එකකට හරි කියලා පෙන්නුවා. And then also we assume that it is true for n equals k, where k is a positive integer, right? Then we were able to show that it is true for in the case n equals k plus 1. Right? That means the next integer. Again, n equals k to hari, k plus 1 to hari kila penno. So that means, you know, by principle of mathematical induction, the result is true for all n is a positive integer. Like that, you can write the final line. Okay, so that is the way to prove this 2025 A-level question. Right, now let's move on to do this question number 2, right? Okay, that is 2024. No? Right. There, using principle of mathematical induction, you have to prove that 7 to the power n minus 1 is divisible by 6 for n is an integer, positive integer. Right. So, this is a statement, right? This is not an equation. This is a statement. Clear? 7 to the power n minus 1 is divisible by 6. Right. So, you think when n equals to 1, right? What we have? 7 to the power n minus 1 equals to what then? 7 to the power 1 minus 1, which is equal to 6. Okay, so we know that this particular answer is divisible by 6. So we can write 6 is divisible by 6. Clear? Then what n equals 1, then my answer is divisible by 6. 6 is divisible by 6. Therefore, the result is true for n equals 1. Clear? Okay, next step, we have to do the assumption, right? Assume that the result is true for n equals k, where k is an positive integer. N equals k, where k is an positive integer. So what? Then you write what you assume. The assumption is 7 to the power k minus 1 is divisible by 6. This is what we assume. Divisible by 6. Clear? 7 to the power k minus 1 is divisible by 6. Now you have to check this for n equals k plus 1. Right. Now consider n equals k plus 1. So how can we write this? 7 to the power k plus 1 minus 1. හරිද? අපි දැන් බලන්න ඕනේ 7 to the power k plus 1 minus 1 එක divisible by 6 ද කියලා. හරි. Now ළමයි, I told you, you have to use this assumption, right? මම යාව use කරන්න ඕනේ. මේ part එක හදන්න. Right. Now think, how can we break this one? I can write this as 7 times 7 to the power k minus 1, isn't it? This part I can write as 7 times 7 to the power k minus 1. Okay, and also I want to form this part. මට මෙයාව හදා ගන්න ඕනේ. මෙන්න මේ 7 to the power k minus 1 කියලා whole part එක හදා ගන්න ඕනේ. But here we haven't formed that. So what I'm doing is, right, I will do something like this. I will write down. හරි, මම මෙහෙම එකක් කරනවා. මට මෙතන 7 to the power k එකට මම මෙතන ලියා ගන්නවා මෙහෙම. You can do this in different ways actually, right? But I'm going to write like this. 7 times T 7 to the power k කියන එක පොඩි කපටි වැඩක් කළා. මම ඒක මෙයා විදිහට ලියා ගන්නවා. හරිද? මම ඒක එකම ලියනවා. 7 to the power k minus 1 minus 1. I hope you can understand. මම මෙන්න මෙයාව තමයි මෙහෙම replace කරේ. ඒක වැරදි. හරිද? අපි වැරද්ද හදන්න ඕන දැන්. Clear? මොකද දැන් මට මේක ගන්නට දා ගන්න ඕනේ. මේ part එක අපි දන්නවා 6 is divisible කියලා. We know that this part is divisible by 6. So what I did is, instead of this 7 to the power k, I just replaced this one with 7 to the power k. දැන් මේව කරපු වැරද්ද හරි ගස්ස ගන්න. Okay, see, 7 into 7 to the power k, we will get this part. Also we have this minus 1 here. You get an extra part. What is that extra part? මේ minus 7 කෙනෙක් එනවා. මොකද මේ මෙතන උඩ line එකේ නැති, previous line එකේ නැති, we are getting an extra minus 7. So you remove that minus 7 by adding plus 7. Clear? So what we get here, 7 to the power k minus 1 plus 6. So can you see this one? When you solve, you get plus 6. Can you see? This part is divisible by 6. This is also divisible by 6. Right? Therefore, the overall answer is divisible by 6. Clear? Therefore, we can write 7 to the power k plus 1 minus 1 is divisible by 6. Okay, so what I did is actually very simple. I just substitute, right? I just use this part. මෙන්න මේ part එක අපි කොහොම use කරන්න තමයි try කරන්න ඕන ගානේ. හරි, ඉතින් මම ඒක ලියාගත්තා. ඒක ලියලා ඒක ලිව්වම වැරදිනේ. ඒ වැරද්ද හදන්න මම මෙතන +7 කෙනෙක්ව දැම්මා. Once you solve this, we get this 6. Divisible by 6 part again. Clear? Right. So you can see that, okay, therefore, the result is through 4. N equals k plus 1. Clear? Okay, right. Then you can write the final line. I think in this video, first part I wrote the final line. We had to write n equals 1. The result is true for n equals 1. If it is true for n equals k, we proved that it is true for n equals k plus 1. Therefore, by mathematical induction, therefore by principle of mathematical induction, the result is true for all positive integers. So you have to write that line, okay? To get, you get 5 marks for that last part also. Final line එක ලියනකොට marks හම්බ වෙනවා. ඒ නිසා ඒ part එක හරියට ලියන්න. I'm not going to write that because it takes time. Okay. ඒක first question එකේදී තියෙනවා ළමයි. මම මෙතනින් එහාට questions වලදී I'm not going to write that part, but still I will just remind you that you have to write it. Okay. Okay. Number 3, 2023 question පුතේ. Right? 2023 A level 1. Right, u1 is given as 2. u1 is equal to 2. Okay, and un plus 1 equals to un plus 2n. They have given another data that un plus 1 equals to un plus 2n. For all n is a positive integer. Okay, using the principle of mathematical induction, you had to prove that un is equal to n squared minus n plus 2. So you have to prove this equation. Or equation එකක් තමයි ළමයි prove කරන්න තියෙන්නේ. හරිද? එතකොට left hand side right hand side කියලා අරගෙන prove කරන්න පුළුවන්. Clear? Right. Now we will write that. එතකොට prove කරන්න ඕන line එකද මේ වෙල data. This is data. These are data, right? Data things. What you have to prove is actually this time prove that un equals to n squared minus n plus 2 for all n is an integer. Hope you can understand what you have to prove and what they have given as data. Clear? Then prove කරන්න තියෙන්නේ මේකනේ. Right. Now you take when n equals to 1. Okay, what is the left hand side when n equals to 1? Left hand side equals to u1. And also put there, they have given that u1 equals to what? 2. Right? Then now put the right hand side. Right hand side the n equals 1 then. So you get 1 squared minus 1 plus 2. So there also you get the answer as 2. Can you see? Left hand side equals to right hand side. Therefore, the result is true for n equals 1. The result is true for n equals 1. Clear? Right. Then do the assumption. Right. Assume that the result is true for n equals k where k is an positive integer. It is assume කරේ මොකද්ද කියලා අනිවාර්යයෙන්ම ලියන්න. Right? What we assumed here. We are assuming that uk is equal to k squared minus k plus 2. Okay? That is uk equals to k squared minus k plus 2. Clear? හරි. එතකොට then අපි n equals k plus 1 කියන case එක consider කරමු. When n equals to k plus 1. Right. What is the right hand side then? When n equals to k plus 1, what is the left hand side? Left hand side, the main equation එක බලන්න මේක left hand side එක වෙනතොර uk plus 1. හරිද? එතකොට බලන්න පුතේ uk plus 1 කියන එක දැන් අපිට මෙන්න මේ තියෙන data එක අපි use කරන්න පුළුවන් උතනදී. uk plus 1 කාටද equal වෙන්නේ? un plus 1 කාටද equal වෙන්නේ? un plus 1 equals to what? un plus 2n. Then what is uk plus 1? We can write as uk plus 2k. Is it clear? And we know that uk equals to this. Okay, so we can write there k squared minus k plus 2 plus 2k. Okay, which is equal to k squared plus k plus 2. Okay, හරි දැන් බලන්න අපි right hand side එක කියලා කාවද එන්න ඕනේ කියලා කාවද derive කර ගන්න ඕනේ කියලා බලන්න right hand side එක විදියට. Right? So what should be the right hand side equals to? But right hand side එක කියලා එන්න ඕනේ මොකද්ද කියලා? when k දැන් මේකනේ අපේ equation එක මේකේ right hand side එකට මොකද්ද එන්න ඕනේ පුතේ k plus 1 නම් n කියන්නේ. That should be k plus 1 squared minus k plus 1 plus 2. Is it clear? You just expand this and see. You can see this is k squared plus 2k plus 1 minus k minus 1 plus 2. Okay, so where this is equal to k squared plus k plus 2. So isn't it the same thing that we have got here? Yes, no? Right, so you can separately show like this, or else also we can just equal this to this one. This is equal to k plus 1 squared minus k plus 1 plus 2, and you can show that we got the right hand side there. Is it clear? It's okay to write right hand side separately and just equal it to k squared plus k plus 2, and then finally write that you got the same thing in on both sides. Is it clear? Right, now then again you can write the final line. Therefore the result is true for n equals k plus 1, and then we can write we proved that this is true for n equals 1, and if it is true for n equals k, this is true for n equals k plus 1. Therefore, by principle of mathematical induction, the result is true for all positive integers. Right. And then question number 4. Right. Using principle of mathematical induction, you have to prove that sigma r equals 1 to n, 1 over r into r plus 1 is equal to n over n plus 1. Okay, right. This is what we have to prove. Sigma r equals 1 to n, 1 over r into r plus 1 is equal to n over n plus 1. You take the case n equals to 1, when n equals to 1. Take the left hand side of this equation. Alright, that means you have to consider the first term of this series. Mayage first term ekai consider karanna one. So when n equals to, the first term of this one will be, I can think n equals, here r equals 1 to n. So 1 to 1 means we have to consider the first term. There we get 1 plus 1. So the answer is 1 over 2. How about the right hand side, lamai? When n equals to 1, 1 over 1 plus 1, that is also 1 over 2. So can you see that the left hand side is equal to the right hand side? Therefore, the result is true for, n equals k plus 1. Is it clear? Therefore, the result is true for n equals k plus 1. Right. Then, okay, now we will do the assumption, right? Assume that the result is true for n equals k, where k is an integer. Right? So what we assume here? Api assumption එක ලියන්න ඕනේ. What we assume? We assume that sigma r equals 1 to k, right? 1 over r into r plus 1, right, is equal to k over k plus 1. Make it the assumption. Now we have to check for n equals k plus 1. When n equals k plus 1. Sigma, left hand side, you can say left hand side is equal to r equals 1 to k plus 1. 1 over r into r plus 1. Then we make main equation n k plus 1 replace karan. Okay, so what do you mean by this? We can write this one as pute sigma r equals 1 to k, or k venakan terms ටික add කරලා හරිද 1 වලින් නම් k වල වෙනකම් value substitute කර add කරනවා. And then we separately add the k plus 1th term. Then k plus 1 r to k plus 1 substitute kale aa venomous add karan. Right, we can write like this: 1 over k plus 1. K plus 1 plus 1 means k plus 2. Aye hum kare? Because we need to use this line. Right, so we know that by the assumption this part is equal to what? K over k plus 1 plus 1 over k plus 1 into k plus 2. Clear? Now you can take the common denominator here, k plus 1 into k plus 2, and what comes to the numerator? K into k plus 2 plus 1. Okay, which is equal to k squared plus 2k plus 1. K squared plus 2k plus 1 over k plus 1 k plus 2. So what you have in the numerator lamai? How the numerator ke mean nidanne ikkene how the k plus 1 whole thing squared ned. Okay, so can you see pute they get cancelled out and it forms k plus 1 over k plus 2. How the me? Or pullo me answer ke pettekin liyaගෙන answer ke target කරගෙන යන්න definitely. Right? me aval liyaගෙන ඒ කියන්නේ දැන් මෙහෙම නේද? k plus 1 substitute කරොත් ඒ කියන්නේ දැන් when n equals to මෙතන when n equals to k plus 1 කියන කේස් එකේදී ඔයගේ ආන්සර් එක වෙනවද මොකද්ද? left hand side එකෙන් k plus 1 over k plus 1 plus 1 නේ. ඒ කියන්නේ k plus 1 over k plus 2 තේරුණා? හරි. ඉතින් ඔක අපිට ඒ කියන්නේ you can just have it as a rough thing and then you can continue to get the answer එකට target කරගෙන යන්න පුළුවන් එතකොට. හරිද? එතකොට අපිට ඔහොම එනවා. So this is actually k plus 1 over k plus 1 plus 1. This is the right hand side that we require. Clear? Therefore, the result is true for n equals k plus 1. I hope you can understand because here when it is k plus 1, as I told you previously, මෙයා k plus 1 වෙනවා, numerator එකේ k plus 2 වෙනවා. ඒ කියන්නේ අපිට දැන් ඇවිල්ලා තියෙන්නේ. Clear? That's it. Right. Okay, then you can write the final line. Therefore, this is true for n equals 1. We assume that it is true for n equals k, and we proved that it is true for n equals k plus 1. Therefore, by principle of mathematical induction, the result is true for all positive integers. Okay. And the last one, question number 5, 2021. Using the principle of mathematical induction, you have to prove that sigma r equals 1 to n, right? 6r plus 1 equals to n into 3n plus 4. Okay. What comes when n equals to 1? Yes, left hand side. You have to consider the first term of the series. So there it is 6 plus 1, 6 times 1 plus 1, which is equal to 7. How about the right hand side of it? Right, when n equals to 1, 1 times 3 plus 4, that is also equals to 7. So can you see that left hand side equals to right hand side? Therefore, the result is true for n equals 1. Clear? Then assume, right? Do the assumption, right? Assume that the result is true for n equals k. n equals k to hari kiyala hitanna, right? Where k is an integer. So what we assume here? We assume that sigma r equals 1 to k, 6r plus 1 is equal to k into 3k plus 4. This is our assumption. Clear? Now you just try to prove it for n equals k plus 1. Then api n equals k plus 1 to prove karamo. When n equals to k plus 1, right? Left hand side is equal to pute sigma r equals 1 to sigma r equals 1 to k plus 1. 6r plus 1. So I can further write down this as I can break it. But 1 to k වෙනකන් sum එක අරගෙන මට k plus 1 කියන term එක වෙනම add කරන්න පුළුවන්. So r equals 1 to k 6r plus 1 plus when you add the k plus 1 term separately මේක k plus 1 substitute කරලා add කරන්න 6 into k plus 1 plus 1. Clear? And then we know this part is equal to what? K into 3k plus 4. Okay. From the assumption that is equal to 3 into k plus 3k plus 4 equals 6k plus 7. 6 into 1, 6 into 1, 6 plus 1, 7. Clear? Okay, now we target the answer. What should be answer? Make the k plus 1 not there. K plus 1 into 3k plus 1 plus 4. Need. This was your answer. Further simplify. K plus 1 into 3k plus 7. Make a gonna try karana hari. Okay. Look at this all of you. 3k squared plus 4k plus 6k we get plus 4k plus 6k plus 10k plus 7. Okay. So isn't it the same factors? Yes, right. So you can factorize it into that, right? We get 3k k and we get 7 times 1 there, 3k plus 7, yeah, 7 times 1, so here plus 8. So like that we can factorize it and then we can write down this format and show. Is it clear? The answer ki target karagattama lesi putte. Hari? Right. Okay, so that is n into n k plus 1 replace la dina 3 into k plus 1 plus 4. Right, so we can write 3 into k plus 1 plus 4. We can write like that into k plus 1. Clear? Which is equal to the right hand side. So right, therefore the result is true for n equals k plus 1. So we have to definitely write the final line by principle of mathematical induction. The result is true for all positive integers. That part we have to write definitely at last. Clear? Right. Thank you.